Hello people, this is Miguel speaking and presenting my lesson 12 homework. Uh, for my circuit, I'm using physical pins 21, 22, and 24 for my for, to power the RGB LED. Here we can see that every channel is connected to its own current limiting resistor, and here we have a ground rail that is connected to Raspberry Pi Pico physical pin 38. Physical pin 38 like this. As you can see, physical pin 21 or GP16 is connected to the red channel. Green is connected to GP17 or physical pin 22, and blue is connected to physical pin 24 or GP18. And I'm using this to show in a better way the color. Under that is my RGB LED. Let's check the code. I want to learn about object orientation with Python, so that's why I create classes. This class in particular is extending machine.pwm, and I created to be able to instantiate a PWM pin with frequency and duty in just one line. I also declare a color class to hold the values for red, green, and blue. And in my homework, this class represents the homework. I declare this variable called selected color to keep the user selection. I declare a initializer that takes a list of my PWM class instances, a dictionary of colors that will be a string, let's say orange, and a color that will be an instance of this class with the proper color for orange, and a string list for valid colors for the colors to be selected for the user from. I have declared this method to show that the colors are working as intended. It is looping through an enumeration of the keys of the dictionary colors in order to get every element and their indexes. Then I use through the key, I access the RGB values and set them to every channel of my RGB LED through the U16 function. I print the key, sleep for 1.2 seconds, and when the list is about to reach its last value, it turns off by setting to the U16 function to 0 and print this message. This function run is represent the logic of the class of the homework, and in selected color I keep the user selection, and if the user selection is in the valid color list, I print the user input and the RGB values for the color selected that is inside the color dictionary. Then I set the RGB values to each channel to do the U16 function, and if the user input is not in valid colors array, it's going to print this message. This try except could be removed because it's not going to capture a value error, because everything is a string when you use the function input. That's what I understand of that. So I'm not going to to show errors. And here is where I instantiate my homework. In this list, this is called list comprehension, and it's looping through these values. These are the pins I selected for my RGB, and for each of them, it's going to create my PWM pin with a frequency of 1000 and a duty of 0. Here is the colors dictionary declaration. In fact, I have these colors with their proper value, and a valid color array that is a list of a string. These are the values that user can choose from. Then I'm looping the function run to ask the user every time for a value until it's interrupted through this exception. Then it is going to turn off every channels by setting to 0 or by using the duty u16 function with a 0 value, and then it's going to print this message. Let's see it in action. I'm going to interrupt this to be able to run the color check function, and it's going to see it in action. Let me change the size of this. Okay, and enter. Now let's see cyan, magenta, yellow, blue, white, orange, red, green, and it's going to stop. Those are the colors. Now let's run it again to check the user inputs. I'm going to use a color that is not in the list. And it says that the color black is invalid because it is not in the valid colors list, and is asking again for the user input. I'm going to use white because on the camera it looks completely white, but watching this in person, I see that this rock show these colors. Shows a little bit of red, a little bit of blue, and a little bit of green. But the camera does not capture that right. The other color I'm proud of is orange because it was pretty hard to find a proper combination for this one. You can see that it does not look like it's each color component is separated. It just looks like orange. Well, it is working pretty well. Green looks pretty good on the camera, and yellow it was also kind of hard to get. It is kind of an orangey, but I can, as white, as happened with white, here you can see little hints of the three colors that combines in the LED to show this one, but in the camera it looks like one color. I'm going to run the function color check again because I really like how it's working. And you can see cyan, magenta, yellow, blue, white, orange, red, and green. Well, that's my homework. Thanks for watching.